Hello and welcome to the screencast. The project we're going to be working on is an application that would allow us to remote control our Raspberry Pi. And what we will specifically want to remote control are basically household appliances like lamps and other electronics. So the first step is we're going to set up a project, start documenting the initial setup, and then running some code. So the project that I'm going to be starting is of course going to be open source. So GitHub is a good place to put that on. Git ignore wise, I'm pretty sure Python. So the programming language that I chose is going to be Python because it's already installed on the Pi. So it's immediately available there and it's simple enough for this project. So the project name is gonna be Switchboard because that's kind of what the project will do. And the license, let's see, do we want GPL or MIT? I guess GPL version 2 would be the best one because I would kind of want people to contribute back their ideas because the whole goal really is about sharing all the things that we do with this little device. So we're going to move ahead with GPL v2, and description is remote control application for the Raspberry. I'm pretty sure I'm not spelling that correctly. Let's autocorrect that, and of course capitalize. A relay application for the Raspberry Pi. Of course, you can always amend that if you happen to find a better name. So let's just create that repository. GitHub has already generated some useful files for us, so I'm going to git clone that repository. And open it up with Atom. Okay, so the first thing is we start writing some code. Wrong. No, we don't write some code first. First, we start documenting. So I already set up my Raspberry Pi and purchased. So I already purchased the relay, hooked it up to my Raspberry Pi, and did some initial setup. However, if I happen to buy another Raspberry Pi, I don't want to. I don't want to start googling again for all these things. So let's start with a readme.md. Let's call it switchboard. And let's first start documenting the components. So on Raspberry Pi. A channel relay module, and let me just quickly check. And we need the pin connectors. So I guess the best, yeah. Yeah, so it's 10 pin female to female. Breadboard jumper wires. And it's actually important to say 8-channel. Actually, the 8-channel part isn't all that important. 5-volt is important. I'm going to provide some examples which might look like, it might feel like hidden advertising. It's not. I just don't know any better way to exemplify this. So initially I'll do this, and if I find any better way to document it, I'll change it. Well, I guess if you want to try it out, it might be easier to just have links ready to go. There we go. So Raspberry Pi, okay, Raspberry Pi, that's already there. That's already there as well. And okay, so here we get a lot more than just 10 cables. We get 40 cables per type, and we get male to male, female to female, and female to male, which I guess it's useful because we could potentially use these on our next project. Okay, so that's there. So these are the components I've used and they worked for me. Of course, there are a ton of different types of relays that we could use. Just to provide a bit of explanation, relays are basically, the way you can imagine relays is as power switches that you can control from the Raspberry Pi. That's, I guess, is the most easiest explanation I can provide. So basically I can hook up a lamp to that relay, and what that allows me to do is switch it on and off from my Raspberry Pi. 8 channels effectively means that I can hook up 8 different things to this relay and control them separately from the Raspberry Pi. So I can hook up a lamp, a toaster, and 6 washing machines and switch them on and off remotely from my Raspberry Pi. I guess if I have 6 washing machines, I'm probably doing some dry cleaning business or something. But the main, I got the 8-channel relay because it felt like it's a what's the word I'm looking for, scalable solution. But of course, if I would have known that I need exactly 2 or 4 or maybe 1 channel, I would have probably bought a 1 or 2 or 4 channel relay. The truth is, I don't really know what I'm gonna use this for exactly. So I wanted to have the most robust solution. That's why I got the 8-channel. So let's move on. So we need these things. and wiring. How is that spelled? Yeah. So we have all the components. We need to somehow wire them together. Now the good thing is YouTube is full of good tutorials on how to do this. So this is the tutorial I followed, and again there are various recommendations here as well what you could use. The good thing about this tutorial, it even has code, so you basically have 90% of what you need to get this done. So we're going to document that. What's also very, very important is to have a diagram of your pins. Because if you don't, then chances are you might accidentally connect things to the wrong pin, and it could easily fry your Raspberry, which is probably not the thing you want. So one useful link is this one. I also have this thing. Okay. So I use this as a reference. I have a Raspberry Pi 3, but of course there are a lot of other diagrams that are just as good. I guess this is probably one of the most useful diagrams because it also shows the orientation. The way I personally connected it up is I use this 5-volt power supply and I use this grounding. And afterwards I use GPIO 2, 3, 4, 17, 27, 22, 23, and 24. The video that I linked, I believe, used 10 and 9 instead of 23, 24. Most of the time it doesn't really make a difference. From what I understood is that all the GPIO pins can be used for this. However, there are these blue ones that have some special properties. You can use them for something a bit more elaborate than just switching things on and off. I guess the most important thing is not to mix up the power and the ground. I guess that's probably the most important thing to get right. Getting these wrong is not a big deal. The worst that could happen is you'll just see that your things aren't working as you imagine, and you're gonna have to correct your program. Okay, so those things are there. All right. So might as well commit this part because having this documentation, in my opinion, is really, really important. Information about the components. Cool. Okay, so this is great. Now the other thing you want to do is you want to have an SSH connection to the Pi. In theory, it is possible to just use the Raspberry Pi as the development machine as well. I tend to run it in headless mode, which means it doesn't start up a graphical user interface. Instead, it just it just runs in command line mode. Just because I don't want to waste resources on graphical user interface, because I'm not going to use the graphical user interface. So if you're going to use it the same way, I suggest setting it up so that it boots into command line mode instead, and just SSHing into the machine. I would also highly recommend setting up a password. So what I did is I did all this. So the Pi boots into command line mode, and like it also has a fixed IP, which is again quite important, is to assign a static IP if you want to access it via the network. This is usually not an issue because the way DHCP works is that the IP that it initially gets is probably the IP it's gonna have in the future. It's just one little bit of extra safety or security. Okay. So now I have my project, and I'm able to SSH into my Raspberry Pi. Where I already have this test py, which is basically the code that I have from this video that helped me do the wire up the Pi with the relay. Which is great because I'm actually going to use this code for a starting point because it's basic, but it has everything that I need. So I'm just going to copy this code, and I'm actually going to put it here. Oh, sorry. I might want to delete this file or make it a bit more generic. For now, I'm not going to bother, but what I do want is I want it to be in the repository for the time being. This is most likely not the final version of this file because it has my setup hard-coded, which is not great. But as I usually say, all in due time. So I have this repository which has this code that I can execute. Now what I want is to remove this ad hoc file, and I'm just going to create a directory called developer, I guess, since this is an all-out Unix system. It's going to be lowercase developer. And what I want is I want to clone my project into this directory. So I have a clear link via Git. Well, I don't believe I have a public private key set up on the Pi, so I'm probably going to have to do that, which of course I don't. So I'm just going to generate a key. And all I'm going to do is I'm going to copy this key to my GitHub so that I can clone the project. Actually, I don't even need to do this because I'm not really planning on making, well, I could go about this both ways. I don't really need a key because I'm just gonna clone it. It's just gonna be read-only. So I'm just gonna need another shell for this. Okay. Should I use SSH? Let's see. Can I use SSH? I don't believe I can because I'm pretty sure this will require me to add the public key. Yes, just as I thought. But I'm just gonna use HTTPS in this case because I just want this to be read-only. There's no reason for me to. There we go. Because ideally, I want to make the mod. I want to develop this on my local machine and then just push it to the Raspberry. I don't really intend on developing on the Raspberry itself. So that's why having git clone read only works for me. There we go. We have our code. Perfect. That's absolutely perfect. And let's see if this thing works. Yes, it works properly. This is great. So we have a Python file here that that can test my GPIO configuration. It's in version control. Everything is documented. Great. However, I kind of want to somehow control this somehow, and I want to do it remotely. And also, this pin list shouldn't really be hard-coded inside the file. So let's try to tackle these issues one by one. And let's try to understand how this code works. So this code first turns on the pins. Okay. Let's try to deconstruct this a little bit. I guess this is a good time to look at the documentation of the GPIO module. And understand its semantics, how it actually works. Okay. Examples, that's always good. Basic usage. Perfect. Okay, so the first thing is we have two modes, BCM or board. I have no idea what each means, so let's try to figure it out. There are two ways of numbering BCM. The first is using board numbering system. P1 header on Raspberry is that your hardware will always work regardless of the board revision. Okay, so this is quite interesting. It's basically the numbering that, so I can potentially set this up in a way where this is more cross device. However, why do they have two different numbering schemes? It looks it's a bit weird, I gotta admit, because let's look at this board numbering system. Why did I see no example use this? There we go. Okay, so I'm not the only one asking this question. That's great. So okay, so I guess the board numbers are these things. That's what I'm guessing at least. Well, the reality is it doesn't change the things we're connecting to. Ah, there we go. So this has changed. It was previously called GPIO 0, now it's called GPIO 2, but the pin layout is exactly the same. This looks like a bit of a blunder, I guess. But realistically, there's no I guess there's no real harm in changing it. Let's try this out, because I guess worst case scenario, it won't actually do anything. So let's try it out. Let's see. So we're gonna set mode to board. And now the numbering should be different. Let's see. So we have 3, 5, 7, 3, 5, 7, 8, 10, 12, 8, 10, 12, 8, 10. Actually, hold on a sec. We didn't actually use 8, 10, 12. So instead I used 11, 13, 15. 11, 13, 15. And 16, 18. That was 16. Okay, so let's try this out. If this works, I guess this is a better way to write this same code. It's less error prone, I guess. I'm gonna get push that, and I'm gonna get pull that here. Since I have read-only access, I can still pull, and let's run the same script. Oh, wow, this works. So I guess this makes a bit more sense. Board numbering. This is really good. I'm gonna have to add this to the README. Documenting this is also important. Okay, this is great. Really happy that I figured this out. Yeah, this clearly shows that writing and reading documentation helps. I mean, we do need to understand what we're working with. So I guess what this means is that the positions of the power sources, the 5-volt and 3-volt power sources and the grounds are exactly the same for all Raspberry Pi models, whereas the, I guess, internal identifier of the GPIOs is not. So that's really good to know. Now let's just see the rest of the code. What's happening here? So we set this, we import time, fair enough, and then we iterate over all of them and set the GPIO setup to GPIO out. Okay, and then we output high. What does high mean? I have no idea, but we're gonna figure it out. Set up a channel, set up more than one channel. Oh, we can actually use arrays here. Now that's good to know. So this means that I can potentially just channel list. Okay, potentially I can get rid of this if statement, and instead of I can just do pin list. Okay. So output. So the output state of GPIO pin. And clean up, that's pretty obvious. So here we're setting those pins to GPIO output. And here we're setting it to high, and here we're setting it to low. So, oh, there we go. What does GPIO high stand for? Because I know what it does. I just want to understand why it's doing it. I'm starting to understand what high and low means. But I want to verify. So GPIO would drive it to 3 volts, and low will set it to 0. For lazy, the alternative is 1. Yeah, that's fair enough. So essentially, we're powering on all our pins. So I guess we're setting up all these pins as outputs, and then we're powering them on with 3 volts. And set mode and state to low, but it's actually setting the mode to high, which I don't understand. Why is it doing it twice? So this seems to make little sense because the output is already on high and we're setting it up again for some reason. I don't quite trust this code, but let us see how the initial code looks like. I have a feeling something's amiss here. So this is the first piece of code that could give us some clue. This makes sense. No. Right. So I think setting it to outputting outputting electricity seems to shut down the switch, whereas not outputting anything seems to close the switch, which I guess can make sense. I should seriously just do my homework on these little bit of electronics. However, the programmer in me just says I should just try to figure this out. So this means I can switch I can have another script or do I want to have another script? I kind of know what's happening here. No, I actually don't want to have another script. What I want to have instead is I just want to have a script that will switch everything on and then everything off. Actually, I'm gonna only switch one thing off. I do need that time sleep. So cleanup, that's important. I'm gonna keep that there. So I guess the sleep is in seconds. So I'm just gonna leave it on for 3 seconds and then clean up. So what I want to do is I want to do something, sleep for 3 seconds just so that pause for 3 seconds just so that I can see if it's working, and then exit. So I have a hunch that, oh wait, I don't think I need that. I just need the output. So if I output 1, 2, 3, 4, so if I on 11 I output GPIO low, that one single switch will turn on. And also I don't want to go to that other tab every time I want to run something. So what I'm gonna do is I'm gonna just run this by SSH developer switchboard git pull. I'm just gonna have test py for now, and it does exactly what I thought it will do. Perfect. Okay, so right, yes, with electronics it does, you do need to understand how it actually works in order to be good at. Okay, so now we basically know that this, we're basically resetting everything. I'm not sure if we need, well, actually we need to do that, because what I saw is that some pins, so these pins don't have a blank initial state for some reason, which I guess is fair enough. So we kind of need to do that. I guess it's mainly the setup that's, yeah. So this is important for us. And this is really about powering on and off one pin. Perfect. This is really, really great. So we have code that sets this whole thing up, and we have code that turns one pin on or off. Actually, let's try the off part as well. Might as well. In theory, this should work, but I don't trust anything until I actually try it. So we just push it, and then we run it on the Pi, and let's see. Yes, this behaved exactly as I have imagined. So we can conclude that this works. I guess the only thing I'm not happy about at the moment is that this list is in the source code. It has no business of being there. So what I want is to put this in a config file instead. Config.json. I'm using JSON because why the hell not? And to be a little bit future proof, I'm gonna have pins. I'm gonna have a property called pins, just so that in the future I'll be able to add other stuff there if I want to. Now I think I need to import JSON, and it's basically json.loads config.json. However, I'm not entirely sure. So fp file like object. Actually, it's probably gonna be load Python JSON from file. Right. Fair enough, makes sense to me. Pprint, I'm not gonna need that. Perfect. So this in theory should, of course, I don't want to check in my config into my Git repository, so I'm just gonna put it under git ignore, because different devices might have different configs, so you need to make sure it doesn't get mixed up. What I want to do though is I want to create this config.json on my server, my pi. That's great. Put pin numbers into config file. Actually, it's more like place pin numbers, but we're just gonna let that one slide for now. Okay, this is perfect. So we had a lot of things working now. Now what I want to do is, instead of test.py, I want to rename it app.py for now. Actually, I want to yes, because I forgot to push this. And I call this thing data and not pin list, and of course it's gonna be did I call that pins? Yes. Might as well add git push to this command. And it works. This is no longer that script. So I guess it's time to make this a little bit less hard-coded and a bit more object-oriented. I guess that's going to be the scope of the next session. But for now, we're happy that we have a working application where most of the things is documented fairly well, and I learned that there are two ways to number these pins, and got a bit of understanding how the electronics part of this works. So stay tuned next time.